It's time to learn math. Hey, I see that. I got your attention, little puppy. I mean, this video's for kids, but you can learn math along with us, or you can keep looking out the window. Whatever's fine. I'm glad you're here. This is going to be a blast. We're going to learn about positive and negative numbers, lines, line segments, and rays. We're going to learn about symmetry. We're going to learn about division and multiplication. And then we're going to learn about probability. It's gonna be awesome. Sit back, relax. It's time for a math adventure. And I want to start by asking you a question. Have you ever heard of positive and negative numbers? Numbers can be positive or negative. That's what we're going to learn about. What makes a positive number positive, and what makes a negative number negative? And what are some real-life examples of positive and negative numbers? Hold tight. We're going to explore all of these questions and more, starting with this. Do you know what this is called? Yeah, it's called a number line. A number line. Which makes sense. It's a line and it has numbers on it, right? A number line is almost like a map of numbers. Numbers always go from least to greatest on a number line. On this number line, what number is in the middle? Yeah, 0. The number 0 is in the middle of this number line. Since number lines move from the least to the greatest number, every number gets bigger as we move down the line. So 1 is bigger than 0, which we know. If you have 1 pancake, that's more than if you have no pancakes, right? I mean, no pancakes, that would be so sad. 1 is greater or bigger than 0. 2 is bigger than 1. 3 is bigger than 2. 4 is bigger than 3. You get the idea. Now, if we move the opposite direction on the number line, every number gets smaller. Yeah. Now, here's something interesting. 0 is not the smallest number. Numbers can go lower than 0. I mean, 0 is in the middle of this number line, which means all of these numbers are less than 0. Numbers that are less than 0 are called negative numbers. Negative numbers, that's what they are. Now, you might have noticed each of these negative numbers has a negative symbol right in front. That's true for all negative numbers, so they're really easy to spot. So numbers that are less than 0 are called negative numbers, which makes sense. They have this negative sign in front of them. Numbers that are greater than 0 are called positive numbers. Positive numbers. They are easy to spot too. Just look for numbers that don't have a negative sign in front of them. So numbers that are less than 0 are called negative numbers, which makes sense. They have this negative sign in front of them. Numbers that are greater than 0 are called positive numbers. Yeah, positive numbers. They are easy to spot too. Just look for numbers that don't have a negative sign in front of them. Let's talk a little bit more about positive numbers. Positive numbers are very common, very common. We see them everywhere. So much so that the main way we write positive numbers is just to write the number all by itself. You can put a positive sign in front of a positive number if you'd like, but you don't have to. Most of the time, it's just the number. Positive numbers, negative numbers. Pretty simple. Wait, what about 0? Is 0 positive, negative, or neither? Well, neither. 0 is actually the only number that isn't positive or negative. It's kind of in the middle of all of them in its own category. 0. It isn't positive or negative. It's, 0. Hey, we use positive numbers a lot, right? We see them all around us, but when do we use negative numbers? Numbers that are less than 0. Check this out. This is footage from Antarctica, the 5th largest continent in the world. What do you think the temperatures are like there? Yeah, super cold. At the South Pole, which is in Antarctica, the temperature can be as low as negative 100 degrees Fahrenheit in the winter. Negative 100 degrees. Wow. If you live in an area that gets really cold temperatures, maybe you've experienced how cold it is when the temperature reaches negative degrees, negative numbers. Wow, numbers so low, they dip below zero. Me, I live in South Carolina, so yeah, the temperature is always in positive numbers here. I don't know what negative temperatures feel like. I can only imagine. Another example of negative numbers is when we look at the elevation of different places on Earth. The elevation of a place is its distance above or below sea level. Now, what's sea level? Well, sea level is how we measure how high or elevated a place is compared to the average height of the surface of the Earth's oceans. Now, if a place is lower than sea level, its elevation is a negative number. For example, a place called the Dead Sea is at negative 1,407 feet. Negative 1,407 feet. In North America, there's a place called Badwater Basin. Badwater Basin. If you are at Badwater Basin, you are at negative 282 feet. That means you are 282 feet below sea level. Of course, elevations can be positive numbers, and most places on land are above sea level. Where I live, I'm at 39 feet, meaning I'm 39 feet above sea level. If you're curious about what the elevation is where you live, you can ask a parent or teacher. It's kind of fun to find out. All right, the last example of negative numbers is if you owe someone money. Debt, or money that's owed, uses negative numbers. For money you get, you would use positive numbers. Okay, you know what? It's time to review. Numbers below zero are called... Yeah, negative numbers. Great job. Numbers above zero are called... Got it, positive numbers. Awesome. And zero, is it positive, negative, or neither? Do you remember? It's neither. Zero is its own thing. Wow, you really know your stuff. Well, that's what positive and negative numbers are. Keep a lookout for them, especially those negative numbers. They are more rare to spot in the wild. You did an amazing job learning about positive and negative numbers. Next, we are going to learn about lines, line segments, and rays. First, let's learn about lines. In math, a line looks like this. You have a line with two arrows, one on each end. These arrows show that the line keeps going on forever in both directions. A line has two arrows. Now, a line segment is so different. It has these two dots, one on each end. These dots are endpoints. It doesn't keep going and going. It starts at one point and then ends at another. This is a line segment. So here's a line. We know it's a line because it has these two arrows. Pretty cool. The arrows show the line keeps going and going in both directions, right? And what's this called? Do you remember? Yeah, a line segment. It has these two dots. They are endpoints. A line segment doesn't go on and on. It has these two endpoints. There's a beginning and an end with a line segment, isn't there? Now, what about a ray? What does a ray look like? Well, a ray is kind of a combo, a combination of the two. You can see it right here. A ray has an arrow on one end, making it like a line on that side, but a ray has a dot on the other side, an endpoint, like a line segment. A ray has an endpoint and an arrow. Array is a combo, right? It has both. All right, so a line has two arrows. It goes on and on in two different directions. A line segment has two endpoints. It doesn't go on and on like a line does. It stops at the endpoints. It's pretty cool. And array has an arrow on one side and an endpoint at the other. That means array goes on in one direction, and then the other side just has that endpoint. Array has both an arrow and an endpoint. Hey, I think it's time. It's time to unlock and discover a super trick. Something used by the true masters and legends of math. A trick you can use to discover if you are looking at a line segment, or array. Even this guy uses the trick. In fact, I think he may be writing me a letter right now. Dear Homeschool Pop, thanks for helping me with my math and for buying me these candles for my birthday. Okay, here's the trick. Just count the arrows and endpoints to see if you are looking at a line segment, or array. You might have picked up on that already. See, we already know that a line has two arrows, a line segment has two endpoints, and array has one arrow and one endpoint. So we count the arrows and endpoints to discover what we're looking at. That's pretty simple. Just count the arrows and endpoints to see if you are looking at a line segment, or array. That's the trick. You know, you've been doing an amazing job learning. I think you're ready for a very special game of Tell Homeschool Pop What You See. Whatever you see on the screen, just tell me. That's it. That's the game, okay? Let's start with this one. What do you see? Yeah, a flamingo. Yes, this is a flamingo. Great. All right, I know, you were probably expecting something different, something related to this video. The thing about this game is you don't know what you will see next. Let's keep going, okay? All right, what do you see here? What is this? Yeah, a line segment. Fantastic. How do we know it's a line segment? It has two endpoints. Two endpoints. This is definitely a line segment. Great job. Okay, what do you see here? What is this? Array. Awesome. Array. How do we know it's array? Yeah, it has an endpoint and an arrow. Very cool. Here is our last one. What do you see here? What is this? You've got it. A line. Sweet. How do we know it's a line? It has two arrows. That's right. It has two arrows. This is a line. Wow. I must say, I'm impressed. You did such a great job. You know what? I'm going to say it. I'm going to say it. You know all about lines, line segments, and rays. You learned so much. You learned this is a line. It has two arrows, right? A line segment doesn't have arrows, but has endpoints instead. And array has one arrow and one endpoint. That's it. Wow, this is a cute bunny. Speaking of cute, I better go feed Mr. Whiskers. Yeah, better. Mr. Whiskers! Mr. Whiskers! I've got to say, you did a fantastic job. You know all about lines, line segments, and rays now. All right, next, we're going to learn about symmetry. Symmetry. If you don't know what that is, that's okay. You are about to find out, like right now, all right? Look at this triangle. It's a yellow triangle with a red border. Sometimes warning signs on the road look like this. To show you how symmetry works, I'm going to place this line down the middle of this triangle. Okay, it's still one triangle, but now it has two sides. Do you notice anything about the two sides of this triangle? Uh-huh. Both sides match each other perfectly, don't they? That's pretty neat. And that's actually what symmetry is. This line is called a line of symmetry. A line of symmetry. If you were to draw this line down the middle of this shape, both sides would match. Aw, look at this butterfly. Does this picture of a butterfly have symmetry? Yeah. If we place a line down the middle of this picture of a butterfly, you can see both sides match each other. Yes, this line is called, do you remember? A line of symmetry. Yeah, a line of symmetry. We know it's a line of symmetry because both sides match each other. Actually, butterflies are symmetrical in real life. The patterns on both of their wings are identical to each other. They match. Butterflies are symmetrical. Let's check out some of the letters and see which ones have symmetry. We can try the first letter, the letter A. Does the capital letter A have symmetry? Yeah, it does. The capital letter A has one vertical line of symmetry, right here. Now, how do we know that's a line of symmetry? Well, we look at both sides. Do both sides match? Yes, great job. Both sides match each other. And if both of those sides match, you know the capital letter A is symmetrical. It has symmetry. That's pretty cool. I like symmetry. Hey, next, how about we look at the capital letter Y? Does the capital letter Y have symmetry? What do you think? Yeah, it does. The capital letter Y has one vertical line of symmetry. You can see it right here. We know it's a line of symmetry because we look at both sides to see if they match. Do they match? Uh-huh, you got it. Both sides match each other. Aw, best friends. I assume they match, they might be friends. When the two sides match, that tells us the capital letter Y is symmetrical. It has symmetry. Pause for a moment, even the music, okay? I need to share something with you. And no, it's not that my true dream and passion is to make cat-themed electronic dance music in honor of Mr. Whiskers, of course. It would be in honor of you, Mr. Whiskers. Let's be honest, it's actually a pretty good idea. I think people might like it. No, this is just something some people don't realize about symmetry, okay? Here it is. Lines of symmetry don't have to be vertical, meaning lines of symmetry don't have to go up and down. Lines of symmetry don't have to be vertical. Take the letter C, for example. Does the letter C have symmetry? Well, if we try a vertical line of symmetry, it would seem like the answer is no. These sides don't match. But wait, if we try a horizontal line of symmetry, do both sides match? Yeah, they sure do. So does the letter C have symmetry? Yes, it does. That means the letter C is symmetrical. Oh wow, here are more butterflies. They are symmetrical. They have symmetry. But I don't think they know that. They go about their whole lives, and I don't think they ever figure that out. Wow. Someone should tell them, right? I don't know. Okay, let's try the letter L. Does the capital letter L have symmetry? Oh, this is going to be fun. Let's check with a vertical line first. Then we can just look at both sides. Do they match? Yeah, they don't match. This is not a line of symmetry. Hey, that's okay. Let's check with a horizontal line, all right? Do both sides match? You're right, they don't. What? No symmetry. Oh. Okay, wait, what's Rover doing on the screen? And what's with the sad music? It's okay that the capital letter L doesn't have symmetry. It's fine. We don't have to be sad. Rover, I promise you, you don't have to be sad. Look, if something doesn't have symmetry, it's this special thing called asymmetrical. Asymmetrical, that's a long word. Asymmetrical. If a letter, picture, or shape has no symmetry, it's asymmetrical. Let's look back on the capital letter L. Remember, the capital letter L has no symmetry. We tried to see if it had a vertical line of symmetry, but these sides don't match. If the sides don't match, you have no symmetry there. Then we tried to see if it had a horizontal line of symmetry, but again, the sides did not match, so there is no horizontal line of symmetry either. The capital letter L has no symmetry. That means the capital letter L is asymmetrical. Asymmetrical means it does not have symmetry. There are other letters that are asymmetrical too. Look at the capital letter R. Let's try a vertical line of symmetry first. Do these sides match? You've got it, they don't match. Wait, how about a horizontal line of symmetry? Do these sides match? Yeah, they don't match either. The capital letter R is asymmetrical. Wait, how about a lowercase r? Can you tell just by looking at it? Is a lowercase r symmetrical or asymmetrical? A lowercase r is asymmetrical too. When you're looking for symmetry, you are looking to see if the sides will match. The lowercase letter r is asymmetrical because none of the sides match. If you try a vertical line of symmetry, these sides don't match, do they? And if you try a horizontal line of symmetry, these sides don't match either. Aha, a treasure map. Actually, this is just a regular map that looks really old. I tried to find footage of a treasure map that has our last letter, the letter X, on it. Okay. But, you know, they have to keep the treasure maps secret. Maybe that's why I can't find that, okay? But the letter X is the last letter we're going to look at. I'm so excited because you are quickly becoming a symmetry expert, okay? So let's look at the letter X together. Now, just by looking at it, do you think it's symmetrical? Is the letter X symmetrical? Yes, it is. We can try a vertical line of symmetry first. Do both sides match? Yeah, they match. But here's the cool thing. We can try a horizontal line of symmetry too. Do both sides match? They do! That means the letter X has 2 lines of symmetry. Wow, that's pretty neat. Be warned, pirates. Some pictures, letters, and shapes have more than 1 line of symmetry. Okay, let's tie all of this together. When you are looking for symmetry, look for sides that match. The line down the middle that shows symmetry is called a line of symmetry. A line of symmetry. If it has symmetry, it is symmetrical. If it doesn't, it is asymmetrical. And if it is symmetrical, it might have more than 1 line of symmetry. So keep that in mind. You did such a phenomenal job. Have fun looking for symmetry all around you, looking for sides that match. You've learned a lot of math so far. Why don't we take a moment and stretch, maybe do a dance move? Yeah, you've done awesome. You really have. Okay, let's see. Let's practice division next. Division. We're going to learn all about division and then put our division skills to work. Aw, these cats have their own compartments for food, so their food can be divided evenly, so each cat gets enough. Because you know, Mr. Whiskers, cats deserve their fair share. If you're new, sometimes I talk to Mr. Whiskers, okay? Anyway, division. Division is when we split a number up by a certain number. Let's say there are 4 apples. Michael and Liam want to split the apples, and they want to make sure it's fair. There are 4 apples, and we are dividing the apples into 2 groups. 1 for Michael and 1 for Liam. 4 divided by 2. This symbol right here is the division sign. It shows us we're dividing. What is 4 divided by 2? Yeah, 2. That's right. 4 divided by 2 equals 2. If Michael and Liam are splitting these 4 apples, they each get 2. Check out this one. Let's say there are 6 bottles of water and there are 6 kids playing outside. That would be 6 divided by 6. If we split the 6 bottles by 6, how many water bottles does each kid get? 1. Great job. 6 divided by 6 equals 1. Everyone gets 1 water bottle. All right, next, let's practice division with school supplies. Let's say there are 9 brand new pencils that 3 students are going to split. 9 divided by 3. We're dividing the 9 pencils between the 3 students so that the students each get the same number of pencils. When we divide 9 by 3, how many pencils does each student get? Yes, 3. Great job! That means 9 divided by 3 equals 3. If you split 9 into equal groups of 3, there are 3 in each group. 9 divided by 3 equals 3. Awesome job! Before we practice more division, I want to ask you a quick question. What is the answer to a division problem called? What is the answer to a division problem called? The quotient. Yeah, the quotient. That's a cool word. Let's say that together. The quotient. Right. Can we say it one more time, just a little louder? The quotient. Yeah, the quotient. Okay, so we practiced 4 divided by 2, which equals 2. 2 is the quotient. We did 6 divided by 6, which equals 1. 1 is the quotient for that problem. And we just did 9 divided by 3, which equals 3. That means 3 is the quotient for that problem. The quotient is the answer to a division problem. And don't worry, Crab, we're going, okay? We have more division to do. Oh my goodness, it's somebody's birthday! Speaking of birthdays, here's a man celebrating his birthday with just 1 candle. I'm not sure what he's saying, but I like to think he's saying, "I put 1 candle on my cake." And she responds, "That's great. That's great." We're going to be dealing with more than 1 candle, though. In fact, imagine we have 7 candles. 7 of them. Now, in the other division examples, we divided a number into multiple groups. But in this example, we are only going to divide 7 by 1, because all of the candles are going on the same cake. 7 divided by 1. And the answer is super simple. How many candles does each group have? Well, there's just 1 group, and all 7 candles are on it. So the answer is 7. Yes, 7 divided by 1 equals 7. 7 is the quotient. Anytime you divide a number by 1, the quotient is that number, because all of it is going into just 1 group. For example, 9 divided by 1 equals 9. It's 9 just getting put into 1 group. 40 divided by 1 equals 40. It's 40 getting divided into just 1 group. 1,000 divided by 1 equals 1,000. It's 1,000 divided into just 1 group. When you divide a number by 1, it's super simple. The quotient is that number. Whoa, look at these 2 bears. These 2 bears are going to share some fish, okay? They're going to evenly divide some fish, okay? Whoa, bears. You both are friends. You both need to share these fish, okay? Evenly. We're going to divide them up. So there are a total of 10 fish, and we are dividing the 10 fish into 2 groups, 1 for each bear. 10 divided by 2. The quotient, the answer to the division problem, will tell us how many fish each bear gets. What is 10 divided by 2? Yeah, 5. Great. 10 divided by 2 equals 5. And you can see each bear gets 1, 2, 3, 4, 5 fish. 10 divided by 2 equals 5. Awesome job. Aw, hello doggies. Are any of you hungry? I'm asking because, well, I have good news for the 4 of you. We have dog biscuits for you to share. We just want to divide them evenly so each of you gets the same amount. We have 12 dog biscuits here, 12 of them, and there are 4 dogs. 12 divided by 4. We have to divide or split up the 12 dog biscuits into 4 equal groups. 12 divided by 4 will tell us how many dog biscuits each dog will receive. What is 12 divided by 4? 3. Great job! 12 divided by 4 equals 3. Each dog will get 3 dog biscuits. 12 divided by 4 equals 3. 3 is the quotient. You are doing an incredible job. Let's try this one next. How many people do you see here? 5. There are 5 people who have been playing outside and are going to take a quick snack break. Thankfully, they brought strawberries. They have 20 strawberries in all and want to divide them amongst each other. This will be fun. So there are 20 strawberries in all, and we are dividing them into 5 groups, 1 for each person. 20 divided by 5. What is 20 divided by 5? Yeah, 4. Awesome! 20 divided by 5 equals 4. That means each person gets 4 strawberries. 20 divided by 5 equals 4. 4 is the quotient. Great! Hey, I think it's time for a division fact. It's division fact time! When you have a division problem, the total number is called the dividend. The number of groups you are splitting it up into is called the divisor. And the answer, as we've already talked about, is called the quotient. Now, a cool thing about division is you can switch the divisor and the quotient, and the division problem remains true. For example, 8 divided by 4 equals 2, but also 8 divided by 2 equals 4. Interesting. The divisor and the quotient can be switched, and the division problem remains true. I'll show you with bananas. Bananas are so tasty! We have 8 bananas here. 8 divided by 4 equals 2. Dividing the 8 bananas into 4 groups means each group has, 2 bananas in it. Cool. Now, if we flip the 4, which is the divisor, and the 2, which is the quotient, it remains true. So 8 divided by 2 equals 4. If we divide the 8 bananas into 2 groups, we see there are 4 bananas in each group. That's pretty awesome. And speaking of awesome, the next example is from the world of tennis. Have you ever played tennis before? Okay. I enjoy tennis. It's a fun sport. Let's say there are a total of 16 tennis balls, and 2 tennis players want to split them up. 16 divided by 2. 16 divided by 2 will tell us how many tennis balls each player will get. What is 16 divided by 2? 8. There are 8 tennis balls in each of these 2 groups. 16 divided by 2 equals 8. Okay, so 16 divided by 2 equals 8. Now remember, the total we are dividing is called the dividend. The dividend is 16. The number of groups you are splitting it into is called the divisor. The divisor in this division problem is 2. And what is the answer to a division problem called? The quotient. Great job! The quotient in this problem is the number 8. Now, we learned that we can switch the divisor and the quotient and it remains true. Let's put that to the test with this. We'll try 16 divided by 8, which will be 2. Here are the 16 tennis balls again, but this time we'll divide them into 8 groups because the divisor is 8. In this case, 8 players are splitting the 16 tennis balls. How many are in each group? Uh-huh, 2. 16 divided by 8 equals 2. Fantastic job. So you really can switch the divisor and the quotient, and the answer remains true. That's really cool. Okay, let's look at a few final division problems. If you don't know the answer, that's all right. Division can take practice, and you'll learn a cool new division fact for next time. Here's the first one. 9 divided by 9. What is 9 divided by 9? Yes, 1. 9 divided by 9 equals 1. If you have 9 and divide them into 9 groups, there is 1 in each group. 9 divided by 9 equals 1. 1 is the quotient. Great job! Here's the next one. 14 divided by 2. What is 14 divided by 2? 7. 14 divided by 2 equals 7. If you have 14 and divide it into 2 groups, each group has 7 in it. 14 divided by 2 equals 7. 7 is the quotient. Fantastic. All right, here's the last one. What is 15 divided by 3? What is 15 divided by 3? Awesome! 5! Yeah! 15 divided by 3 equals 5. If you have 15 and divide it into 3 groups, each group has 5 in it. 15 divided by 3 equals 5. 5 is the quotient. You did such an amazing job. Even if you didn't know all of these, you are well on your way to being a division master. Aw, the cats from earlier. The food was divided up, and each cat has enough. The magic of division. Anything to add, Mr. Whiskers? That's okay, Mr. Whiskers. Division means a lot to me, too. That was fun. All right, next we have the opposite of division, which is multiplication. I'm curious about something. If you'll just wait a moment, I have a question for some animal friends. Do you know how to multiply, giraffe? No? Okay, do you know how to multiply? Well, these giraffes should keep watching because we're all going to get some great multiplication practice in this video. Multiplication is when you have a number a certain number of times. For example, a standard bike has 2 wheels, but if there are 2 bikes, then you have the number 2 2 times. In other words, 2 times 2. That's multiplication. This x tells us we're multiplying. The number 2 2 times is the same as 2 plus 2. It's the number 2 twice. How many wheels are there in all? What's 2 times 2? Yeah, 4. 2 times 2 equals 4. There are 4 wheels in all. You know, a motorcycle has 2 wheels also. Whoa, here are 3 motorcycles. To find the total number of wheels, we have the number 2 3 times. 2 times 3. 2 times 3 is the same as 2 plus 2 plus 2. It's the number 2 3 times. What is 2 times 3? Yeah, 6. There are 6 wheels in all. 2 times 3 equals 6. There are a total of 6 wheels when you have 3 motorcycles. Great job. Cookies. Yeah, let's practice multiplication with cookies next. Let's say a store sells boxes of cookies. There are 3 cookies in each box, and someone buys 3 of these boxes of cookies to enjoy with some friends. Now, to figure out how many cookies there are in all, you would multiply the 3 cookies times 3, because there are 3 boxes. 3 times 3. This is the same as 3 plus 3 plus 3. It's the number 3 3 times. What is 3 times 3? 9. Awesome! 3 times 3 equals 9. That means there are 9 cookies in all. 3 cookies 3 times means there are 9 cookies. We could even count the cookies to double check. 3 cookies 3 times. 1, 2, 3, 4, 5, 6, 7, 8, 9. 3 times 3 equals 9. I don't know if I've mentioned this in any of my videos, but I love basketball. It's my favorite sport. I was obsessed with basketball as a kid and collected basketball cards. Actually, I still have my basketball cards. I keep them in my office and still look at them from time to time. They're really cool. Now, why am I sharing this? Well, when you collect cards, you're used to using multiplication. Let's say a new series of basketball cards has 6 cards in every pack. Every pack has 6 cards. And I have enough money to buy 3 of these packs. To find out how many cards I'm getting in all, we have to multiply 6 times 3. It's the number 6 3 times. This is the same as 6 plus 6 plus 6. It's the number 6 multiplied times 3. What is 6 times 3? Yeah, 18. Great! 6 times 3 equals 18. I'm getting a total of 18 cards. We can just double check that real quick. 6 times 3 means we have the number 6 3 times, which is the same as 6 plus 6 plus 6. 6 plus 6 equals 12. Yeah. And 12 plus 1 more 6 is 18. Yeah. 6 times 3 equals 18. Let's try another one. What is 8 times 1? What is 8 times 1? Yeah, 8. 8 times 1 equals 8. Now, why is that? Well, if you have the number 8 just one time, you just have 8. Actually, any time you multiply a number times 1, the answer is that number. Going back to bikes, you know that a bike has 2 wheels. If you have one bike, to find the total number of wheels using multiplication, you could multiply 2 times 1. 2 wheels, once. The number 2, just one time. And what's 2 times 1? Yeah, 2. 2 times 1 equals 2. If you multiply any number times 1, the answer is that number. For example, 9 times 1 equals 9. It's 9 just one time. 12 times 1 equals 12. It's the number 12 one time. 100 times 1 equals what? 100. It's 100 just one time. Great. Let's give this one a shot. 7 times 0. What do you think 7 times 0 is? Yeah, 0. But why is that? Well, if you have a number 0 times, you have 0. 7 times 0 equals 0. 7 times 0 means the number 7 0 times. The answer is 0. Whenever you multiply a number times 0, the answer is 0. 1 times 0 equals 0. It's the number 1 0 times. 5 times 0 equals 0. It's the number 5 0 times. 10 times 0 equals 0. What is 1 million times 0? You got it, 0. Awesome job. Aw, look at these puppies. Come over here, puppies. We're going to practice more multiplication. Come on. Hey, let's try this one. What is 4 times 2? What is 4 times 2? Yeah, 8. 4 times 2 equals 8. Great job. 4 times 2 is the number 4 2 times. This is the same as 4 plus 4. It's 2 4s, and 2 4s equals 8. 4 times 2 equals 8. Okay, let's try 5 times 3. What is 5 times 3? Yes, 15. 5 times 3 equals 15. Sweet. 5 times 3 is the number 5 3 times. This is the same as 5 plus 5 plus 5. It's 3 5s. 5 plus 5 equals 10, plus another 5 is 15. 5 times 3 equals 15. Next, let's try 1 times 4. What is 1 times 4? 4. Very cool. 1 times 4 equals 4. If you have the number 1, 4 times, you have 4. You might have picked up on this already, but with multiplication, the order of what you are multiplying doesn't matter. The answer is the same. 4 times 1 equals 4. 1 times 4 equals 4. If you flip the 4 and the 1, the answer is the same. The answer is 4. I'll show you with pizzas, okay? Let's say there's going to be a big party, right? And a pizza place has a 4 pizza deal. It's a special deal that gets you 4 whole pizzas at a lower price per pizza. You get 1 4 pizza deal. It's 4 times 1. The number 4 once. 4 times 1 equals 4. So you have 4 pizzas. Now, if you flip the order and switch the 1 and 4, the answer is the same. See, this is the same as if you multiplied 1 pizza 4 times. That would be 1 times 4 equals 4. Both work. You can flip these numbers in multiplication, and the answer stays the same. Oh, it's question time. It's question time. I have a question for you. What is the answer to a multiplication problem called? What is the answer to a multiplication problem called? Yeah, the product. The answer to a multiplication problem is called the product. For example, 5 times 2 equals 10. 10 is the answer, so it's called the product. 0 times 6 equals 0. 0 is the answer, so 0 is the product. The answer to a multiplication problem is called the product. Let's go ahead and look at a few more. What is 3 times 4? What is 3 times 4? Yeah, 12. 3 times 4 equals 12. Phenomenal job! And as we just learned, 12 is the product. It's the answer to this multiplication problem. 3 times 4 means we have the number 3 4 times. It's the same as 3 plus 3 plus 3 plus 3. The number 3 4 times. 3 plus 3 equals 6. So each of these pairs equals 6. And what's 6 plus 6? Yeah, 12. That means 3 times 4 equals 12. Wow, we're in Egypt. That's pretty cool. That's pretty cool. Let's try 5 times 6. What is 5 times 6? What is 5 times 6? 30. Very cool. 5 times 6 equals 30. This is a big answer, isn't it? 5 times 6 is the number 5 6 times. To double check this, we can count by 5s. 5, 10, 15, 20, 25, 30. 5 times 6 equals 30. Great job! 30 is the product, the answer to this multiplication problem. Okay, here's the last one. What is 10 times 7? What is 10 times 7? Yeah, 70. Awesome! 10 times 7 equals 70. This can be illustrated using dimes because dimes are worth 10 cents. 10 times 7 means the number 10 7 times. Each dime is worth 10 cents, and there are 7 of them here. 10 times 7. To check our answer, we can count by tens. 10, 20, 30, 40, 50, 60, 70. 10 times 7 equals 70. 70 is the product. Wow, Well, giraffes, do you understand multiplication now? You didn't watch? You were eating. Okay, gotcha. Well, maybe next time, you know? All right, so that was multiplication. We only have one more lesson left. The final lesson. What? You are about to learn about something that's pretty cool called probability. 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 Probability is the chance of something happening. That's pretty simple. Probability is the chance of something happening. I'll show you how it works using coins. Yeah, coins are fun. Especially to spin, okay? Look at this spinning penny, and it might look like the penny's alone. Don't worry, the penny has coin friends. Let's say you have these 5 coins, 3 pennies, 1 dime, and 1 nickel. You decide to randomly pick a coin to spin on a table. This is going to be a totally random pick. You aren't going to peek. If you randomly pick one of these coins, how likely are you to pick a penny? That's a good question. Well, more than half of these coins are pennies, so the answer is likely. You will likely pick a penny. Likely means there's a big chance. Okay, how likely are you to pick a dime? Well, that's different. There's only 1 dime. Only 1 out of the 5 coins is a dime. How likely are you to pick a dime? The answer is unlikely. Unlikely meaning there's a chance, but you probably won't. You are unlikely to pick a dime. Well, let's not leave out the nickel. How likely are you to pick a nickel? Well, let's think about it. There's just 1 nickel out of 5 coins, just like we had with the dime, which means there's a chance you might pick the nickel, but you are unlikely to pick it. The answer is unlikely. You are unlikely to pick a nickel. All right, here's another situation. Say you are at a baseball game and you found some pennies. 4 pennies, in fact. Just to be silly, you decide to randomly pick a coin in your pocket to see which kind you pick, even though all 4 coins are pennies. How likely are you to pick a penny? Well, you have to pick a penny, right? Because that's the only option. You are certain to pick a penny. The answer is certain. In probability, we use the word certain to mean there's no chance of anything else happening. You are certain to pick a penny, 100%. Now let's look at a completely different scenario. Say I want a green balloon because green is my favorite color in the whole world, which it actually is. I don't know why, it just is. Green has always been my favorite color. All right, so I go to a store to try to buy a green balloon, but I don't know they only have red and blue balloons. All the other balloons are sold out. How likely am I to buy a green balloon at this store? Well, there aren't any green balloons, so there is no chance. It is impossible to buy a green balloon from this store on that day. Impossible is the word used in probability when there is no chance of that outcome happening. I can't buy a green balloon from this store right now. It's impossible. I'm just kidding. It might be impossible to buy a green balloon from this store today, but there's no way I'm giving up. I can go somewhere else and look for a green balloon, or come back here another day once they get more green balloons in. All right, so probability is the chance of something happening. There are words we use to describe the probability of an event. There's certain. That means you have a 100% chance. It will happen for sure. There's likely. That means you have a big chance. There's a big chance it will happen. Then there's unlikely. That means there's a little chance of it happening. And lastly, the term impossible, meaning zero chance. Just like there was zero chance of me getting a green balloon at the store that day. That does not mean it will always be impossible. In fact, the probability or chance of something happening can change. Maybe you find another coin at the baseball game, a nickel this time. Or maybe a delivery truck arrives and suddenly I do have a chance of getting a green balloon at that store. Okay, now it's time for a probability quiz. I need your help. Pretend you are at a movie theater. You've been picking up coins you found along the way, 7 in all. 4 nickels, 2 dimes, and 1 penny. While you wait for the movie to start, you pick coins randomly without looking. How likely are you to pick a nickel? How likely are you to pick a nickel? Likely. Correct. You are likely to pick a nickel. More than half of the coins are nickels. You have a big chance of picking a nickel. That means it is likely. You are doing great. All right, how likely are you to pick a penny? A penny. How likely are you to pick a penny? Unlikely. You are unlikely to pick a penny. There's a chance you could pick a penny, but it's just a little chance. Unlikely. What's next? Oh, how likely are you to pick a dime? A dime. How likely are you to pick a dime? Unlikely. Yep, you are unlikely to pick a dime. With only 2 of the 7 coins being dimes, there's only a small chance you'll pick a dime. Unlikely. Okay, here's the final question. How likely are you to pick a quarter? A quarter? How likely are you to pick a quarter? It's impossible, yes. If you only have these 7 coins, it's impossible to pick a quarter because none of them are quarters. It's impossible. But remember, if you find a quarter later on, add that to your collection and play the same game, the probability would change. It wouldn't be impossible anymore, but it would be unlikely. So, probability is the chance of something happening. There are words we use to describe the probability of an event. There's certain. That means you have a 100% chance. It will happen for sure. There's likely. That means you have a big chance. There's a big chance it will happen. Then there's unlikely. That means there's a little chance of it happening. And lastly, the term impossible, meaning zero chance. Just like there was zero chance of me getting a green balloon at the store that day. That does not mean it will always be impossible. In fact, the probability or chance of something happening can sometimes change. You did such a wonderful job learning about probability, the chance of something happening. I think Mr. Whiskers is likely to agree. No, he's certain to agree. 100%. 100%. Mr. Whiskers. You are such a math champ. You learned so much math. And you've made it to the end. So awesome. If you haven't subscribed and you enjoy my videos, consider clicking the subscribe button. Thank you to my patrons. And thank you for hanging out with me and learning. I had a blast. I hope you did too. And I will see you next video.